Assalamualaikum everyone, my name is Nurin Nabila from AS244. Today I am going to present my final year project about the evaluation of tennis producer Bacillus cereus KY622536 and KT18054 from ruminant cat flu. First and foremost, what is tannin? Tannins are naturally occurring polyphenolic compound found in many plants. They are known for their ability to bind and precipitate protein, which contribute to their characteristic bitter taste. Tannins play a crucial role in plant defense mechanism against herbivores and pathogens due to their bitterness and protein precipitating properties. They are widely distributed across the vegetative kingdom in both terrestrial and aquatic habitats. Then, what is tannins? Tannins is the enzyme that catalyzes the hydrolysis of tannins. Several bacterial species such as Bacillus cereus can produce large amount of tannins. Solid-state fermentation is frequently used for tannins production through the bacterial and fungal sources. When ruminants consume diet containing tannin, this plant secondary metabolite can have both positive and negative impact on ruminant fermentation, nutrient digestibility, animal performance, and detoxification system. Bacterial tannins, composed of a single subunit of polypeptide chain, can be cloned, overexpressed, and purified efficiently. Excessive tannin consumption can limit the absorption of important minerals like iron and calcium, potentially leading to the nutrient deficiencies. Tannin inhibit ruminant nitrogen metabolism by inhibiting proteolytic microorganisms, posing significant challenges. Due to that, our objective for this study are to in vitro characterize Bacillus cereus strain KY622536 and KT7188054 using morphological and biochemical tests. Next, to evaluate the optimal tannins activity of Bacillus cereus under various parameters such as pH and temperature, and to determine the antimicrobial resistant profile of the isolated Bacillus cereus strain against the commercial antibiotics. For the methodology, there are three main methods that has been used, which is firstly to characterize the Bacillus cereus strain morphologically with biochemical tests and thin layer chromatography. Next, to characterize the crude tannins under different parameters. The crude tannins were obtained by fermented in fermentation medium and centrifuged under 5000 rpm for 15 minutes, and the tannins activity was measured at 520 nanometer by using spectrophotometer. Lastly, antimicrobial resistant profile. Both Bacillus cereus strain were tested against 9 commercial antibiotics by using distribution assay. And crude tannins, with selected 4 types of antibiotics, were tested against MRSA, Klebsiella, and Staphylococcus using distribution assay as well. Move to the result and discussion. For in vitro characterization, as shown in table 1, the Bacillus cereus strain exhibit distinct colony morphology, being large in size, round, and off-white in color. Under the microscope, it was observed to be rod-shaped and arranged in chains. Both strains were gram-positive, appearing purple due to their thick peptidoglycan layer. For biochemical tests for both Bacillus cereus strain that indicate all positive results except for indoor tests that specify that Bacillus cereus absent of the tryptophanase enzyme responsible for breaking down tryptophan into indole pyruvic acid and ammonia. Thin layer chromatography was utilized to detect gallic acid, a product of tannin hydrolysis. The presence of gallic acid confirmed the activity of tannins in breaking down tannin into gallic acid. Next, for tannins characterization, Bacillus cereus was fermented for 5 days to obtain the highest tannins activity. Bacillus cereus KY622536 showed the highest tannins activity on day 2 with 13.84 U per mil, while Bacillus cereus KT7188054 showed the highest activity on day 3 with 7.43 U per mil with statistically significant difference less than 0.05. Both growth profiles of Bacillus cereus exhibited a sigmoid growth curve. Based on the other studies stated that Bacillus species typically show optimum activity between day 2 and day 4. Next, for tannins characterization, Bacillus cereus was fermented for 5 days to obtain the highest tannins activity. Bacillus cereus KY622536 showed the highest tannins activity on day 2 with 13.84 U per mil, while Bacillus cereus KT7188054 showed the highest activity on day 3 with 7.43 U per mil with statistically significant difference less than 0.05. Both growth profiles of Bacillus cereus exhibited a sigmoid growth curve. Based on the other studies stated that Bacillus species typically show optimum activity between day 2 and day 4. Notably, tannins activity increased by a fold increment of 3.57 for Bacillus cereus strain KY622536 and 6.42 for Bacillus cereus strain KT718054. This result demonstrates a gradual increase in TNase activity under optimal condition, highlighting the potential for Bacillus cereus in genetic engineering and advanced fermentation technologies to enhance production and stability. Antibiotic susceptibility testing revealed distinct profile for Bacillus cereus strain KT718054 and KY622536. Both strains exhibit resistance towards antibiotic, sulbactam, cefoxitin, and penicillin G, that indicating intrinsic resistance to these antibiotics. Tigecycline and vancomycin show intermediate susceptibility with smaller inhibition zone against the bacteria. In contrast, ciprofloxacin, chloramphenicol, gentamicin, and streptomycin were found to be effective as this antibiotic demonstrates susceptibility against both Bacillus cereus strain. This finding underscored the importance of understanding antibiotic resistant profile in Bacillus cereus, particularly in environment where these bacteria may interact with human or animal population. In this table 5, the highest increase in fold area in combination with antibiotic and crude TNase was marked in red border. Combining TNase with antibiotics has shown synergistic effect in inhibiting bacterial growth. Study by Ahmed et al. Demonstrated that TNase exhibit potent antimicrobial activity against a range of pathogens, including Streptococcus and Klebsiella. These effects are characterized by lower minimum inhibitory concentration and increased diameter of inhibition zone when combined with antibiotics. Understanding this mechanism underscores the potential of TNase as a promising antimicrobial agent with application in medical and environmental settings, potentially offering new strategy to combat antibiotic-resistant bacteria. In conclusion, the Bacillus cereus KY622536 and KT718054 were found as round-shaped white color morphologically. And with indoor tests indicate negative result, thus prove that Bacillus cereus cannot break down tryptophan to produce indole. Bacillus cereus have highest TNase activity 49.43 U per ml and 47.73 U per ml at optimum temperature of 40 degrees Celsius and pH 5. With the possible potential to tolerate higher pH at pH 8 and tannin concentration 1.6%. Crude TNase from Bacillus cereus were found to possess antibacterial activity against MRSA, Klebsiella, and Staphylococcus. It also shows synergistic effect when combined with the antibiotics. For recommendation, further research on whole genome sequencing to explore the genetic basis of TNase production and antibiotic resistance, expand biochemical tests, and use molecular technique like qPCR to study the gene regulation. Here is the reference that has been used for this presentation. Thank you for listening and your attention.